Welcome to the webinar, How Next-Gen RAN Powers Location-Based Services and Lawful Interception in 5G. In this bite-sized webinar, we will explore how real-time location data has become more important than ever, and how advancements brought about by 5G will significantly enhance location detection accuracy and speed, leading to greater location intelligence and improved public safety and emergency response. I'm Ariana Lin, Principal Analyst and Senior Editor at the Fastmod. And with me today, I have Michael Gabrasadik, Location Product Manager at SS8, a leading lawful and location intelligence solution provider. Michael has over 2 decades of experience in location technology, having held roles in engineering, product management, and business development. We will begin with the Fastmod session, which will briefly introduce location-based services. We will then look at the role of telcos in the LBS ecosystem, specifically the advantages of network-based LBS. We will then look at a series of use cases and monetization opportunities and the challenges that accompany the implementation of LBS. The session will conclude with a discussion of 2 recent case studies in the telco LBS space. This will be followed by a presentation by Michael, who will explore the intersection of location technology and public safety. Michael's session will cover an introduction to SS8, the benefits of location technology in enhancing public safety, real-world use cases, and the evolution of location detection technology, primarily the transformative impact of 5G on location accuracy. If you have any questions throughout the session, please input them into the chat box on the right side of the screen. We will reach out to you via email with the answers and feedback. We will also get in touch with everyone who signed up with a full recording of this webinar. Okay, so let's begin. Location-based services, as the name implies, are a category of applications that leverage location detection, or in other words, positioning technologies, to enhance user experiences based on their physical location. In essence, LBS uses location data to provide personalized content or functionality tailored to the user's specific geographic location, adapting online experiences to their real-world context. On the slide, you can see how LBS is essentially made up of 4 components: the device, which can include a smartphone, a tablet, an IoT device, a wearable such as a smartwatch, or an in-car navigation system; the location positioning technology, which includes network-based methods such as cell ID, TOA or AOA, and terminal-based methods such as GPS, AGPS, RFID, and Bluetooth; network connectivity, which includes 3G, 4G, and 5G mobile networks, Wi-Fi, and satellite connectivity; and lastly, the application server and database, where location data is received from the device over the network and interpreted and processed and then used to deliver relevant and tailored information or services back to the user. In this ecosystem, telcos have long been seen as purely providers of network connectivity, the third component. However, we will look at why this perception is evolving and how telcos are becoming integral players in not just supporting but delivering location-based services. Before that, let's quickly look at the market for location-based services. According to Allied Market Research, the location-based services market was estimated at $45 billion in 2021 and will grow at a CAGR of 24.6% to a staggering $402 billion by 2031. While outdoor LBS dominates the bulk of this market, demand for indoor LBS is similarly rising and expected to hit $45.3 billion by 2030, according to Grandview Research. The market presents much untapped potential, with only 2/3 of US smartphone owners having used location-based map and navigation services in 2021, as per a report by Insider Intelligence. Okay, so back to the role of telcos in providing LBS. Telcos have several advantages or prerequisites in place which enable them to easily roll out and offer network-based LBS. Firstly, telcos boost extensive existing infrastructure. With a wide coverage area, the implementation of LBS requires little to no additional investment, accelerating the deployment process and ensuring that users can access location-based services seamlessly from anywhere. Secondly, network-based location detection offers enhanced reliability compared to terminal-based location detection. This includes a faster time to first fix, reducing the time users need to wait for location information. Unlike GPS-dependent alternatives, network-based LBS delivers significant battery savings, a crucial factor for mobile devices, and operates without the need for specific apps or hardware, supporting a wide range of devices including IoT devices and vehicles, and works indoors and in location with an obstructed line of sight to satellites. This trustworthiness and reliability is further underscored by their resistance to tampering, unlike technologies reliant on a handset or device for reporting. These advantages are further compounded by the advent of 5G, which offers high-speed connectivity, accuracy levels of less than 1 meter, precise indoor positioning, and more. Michael will later go into detail on the advancements brought about by 5G and how they significantly enhance location accuracy. The third factor is telco's vast and established customer base, a crucial asset for the widespread adoption of LBS. The trust already built with existing customers facilitates the acceptance of location-based services, contributing to higher opt-in and consent rates. Furthermore, location data obtained by the telco is authentic, as customers are registered and verified, unlike on, for example, social media websites. Telcos also have access to existing user profiles, preferences, and billing information, enabling them to enrich overall user experience by tailoring location-based services to individual needs. And lastly, real-time location systems for emergency callers, geo-targeted emergency communication, and access to location history are mandated in many jurisdictions, which means that the majority of telcos have or will have location intelligence platforms already established. As these systems are already in place, monetization is simple and clearly the next logical step forward. Okay, so moving on to some potential monetization opportunities, we have split telco LBS use cases into 3 segments. The first, as you can see on this slide, involves applications that telcos can offer directly to subscribers. These are fairly simple applications that do not require much setup. For individual subscribers, pull applications include real-time location sharing and tracking, and push applications include location-based offers and recommendations, and information and updates. Examples of the former include a phone or watch finder, a real-time location sharing feature for meetups, a pet tracker, and more. For enterprise subscribers, applications include asset, fleet or inventory management, geofencing, and fraud and theft prevention. Okay, so the second type of LBS is offered via the use of telco APIs. These services require user-specific real-time location information but are too complex for a telco to set up and run by themselves. By partnering with third-party application developers and offering location APIs for subscription or pay-per-use fee, telcos can enable a wide range of use cases, including maps, routing and navigation, location-based social networking, location-based gaming, fitness and physical activity tracking, tourism information, nearest store locators, autonomous driving, augmented reality, e-hailing and delivery, and more. And the third and final type of LBS is location-based big data. Long-term and short-term location and movement data is compiled and anonymized and offered to enterprises and organizations for a variety of use cases. This big data can be offered on a subscription basis, a pay-per-use basis, via licensing, on a partnership or collaborative model, or as a bundled service. On this slide, you can see 3 use cases. The first is location-based advertising and marketing, where businesses leverage the geospatial data to target their advertising and marketing efforts more effectively. This includes sending location-specific promotions, personalized advertisements, and targeted campaigns to users based on their real-time or historical location data. By understanding consumer behavior and preferences, businesses can optimize their marketing strategies and maximize customer engagement and response. The second use case revolves around location-based analytics and insights. Enterprises can employ this big data to gain deep insights into customer behavior, foot traffic patterns, and demographic trends. Such analytics enable businesses to make data-driven decisions and develop predictive models. Whether it's optimizing store layouts, pinpointing high-traffic areas, or identifying peak business hours, location-based analytics empower organizations to enhance operational efficiency and customer satisfaction. And lastly, we have location-based surveys and feedback. By deploying real-time location-based surveys, businesses can collect feedback on various aspects such as in-store experiences, service quality, and product preferences at specific locations. This targeted approach allows for more relevant and context-specific feedback, enabling businesses to make improvements tailored to the needs and expectations of customers in different geographic areas. Additionally, this leads to more effective and accurate market research. As we explore the monetization of big data, we note a number of challenges that telcos should be aware of. Firstly, there's the delicate task of balancing the usage of location data with user privacy concerns and ethical considerations. This requires a fair and responsible use of location data and a commitment to transparency, ensuring users are well informed about how their location data is utilized. On the technical front, compiling, analyzing, and verifying millions of data points 24/7 requires advanced processing and storage capabilities. Navigating local regulations and data protection laws presents an added layer of complexity, and obtaining explicit user consent is not any easier. And lastly, protecting all of this data from reaching the hands of a cyber criminal is another huge challenge, which requires robust cybersecurity measures, including strong encryption, regular security updates, and proactive monitoring to prevent unauthorized access. In spite of these challenges, there are plenty of opportunities in location-based advertising and marketing, especially considering recent events. Major web browsers like Chrome plan to phase out third-party cookies by early next year, which will shift conventional web advertising approaches. Apple, through its iOS 14 and 17 updates, introduced app tracking transparency and link tracking protection, which results in pretty huge implications for contextual advertising. In fact, certain studies suggest a link between Apple's announcements and a decline in the growth of overall internet advertising revenue in the last year. Additionally, there's a growing amount of state, country, and regional data privacy and security legislation limiting advertisers in methods and data use. This creates a growing need for an alternative method for contextual and targeted advertising, presenting a substantial telco opportunity. And the market, well, it's poised to grow from 96 billion in 2021 to a whopping 278 billion in 2031, with a 15.1 CAGR, according to Grandview Research. We therefore see great potential for telcos in the monetization of big data. Okay, so let's examine a recent and successful telco case study involving location-based big data monetization. Vodafone Analytics was launched in 2017 by Vodafone Business, the B2B division of Vodafone, the largest telco in Europe and one of the largest telcos across the globe, with over 625 million mobile customers. The end-to-end platform offers data and insights into both real-time and historic subscriber location and was designed in such a way that organizations could easily visualize and understand location and mobility data. The solution leverages capabilities developed by CityLogic, Kato, and Cellfocus and offers various modules, including Vodafone Analytics Footfall, Vodafone Analytics for Retail, and Vodafone Analytics for Tourism. Other use cases include real estate, logistics, public sector, outdoor media, and insurance. In April 2020, Vodafone migrated the solution to Google Cloud. The primary reason was to support the European Commission and the GSMA's request for location data to help control the COVID-19 pandemic. Vodafone's platform was used to predict the cause of the pandemic, evaluate the impact of lockdowns, and correlate population mobility with disease outbreaks. Google Cloud was used to anonymize, aggregate, and verify the data collected, ensuring that raw data or any personally identifiable information is never shared. This approach, along with the option for subscribers to opt out, ensures compliance with privacy standards while still providing valuable insights. As of 2 years ago, the platform had over 100 customers, including retailer OVS, real estate firm JLL, and cable channel MTV. The platform more recently demonstrated its capabilities by monitoring traveler and pilgrim movement during World Youth Day 4 months ago. Our second case study looks at SFR Geostatistics, introduced by SFR, the second largest and second oldest telco in France, through its B2B arm SFR Business. The solution harnesses geospatial intelligence from SFR's extensive network of 21 million European mobile users, storing up to 24 months of historical data. Data collected includes the number of people heading towards or leaving a location, the number of people at the location and the amount of time they spent there, and so on. The solution aggregates and presents location and mobility data in a simple online data visualization interface powered by Open Datasoft technology. SFR Geostatistics caters to a diverse range of sectors, including tourism, event planning, retail, advertising, real estate, the public sector, and banking. Similar to the previous case study, SFR Geostatistics was used during the COVID-19 pandemic by APHP, a group of hospitals in Paris, to build predictive models, contributing to a deeper understanding and control of the pandemic. The platform is also used by BFM Regions, a French news network, to generate annual insights on tourist movement in and out of France. Okay, so on this slide we list several important use cases for location intelligence, but which don't go under the traditional umbrella of location-based services. These use cases do not directly present any monetization prospects, but can be used as opportunities to create brand awareness and enforce wider brand or CSR strategy. Additionally, some are required by the law, as we mentioned earlier. Use cases include the provision of real-time location for emergency services, historic and real-time location and movement data for crime and safety, geo-targeted communications and location monitoring for natural disasters or other crises, big data for smart city management, and location intelligence for pandemic or epidemic management. Okay, so I'm now handing over the session to Michael, who will discuss the importance of location information for public safety and law enforcement specifically. He will provide a detailed explanation on the evolution of network location technology, the impact of 5G, and why SS8 stands out in this space. Over to you, Michael.
Thank you, Ariana. Hello, I'm Michael Gabrasadik, Director of Product Management, working in the location division of SS8, providing solutions to law enforcement, emergency services, and mobile operators. First off, I'd like to thank FastMode for hosting this webinar and giving SS8 the opportunity to speak about something that we are quite passionate about, public safety and saving lives. In this session, I want to show you how advanced network-based location can transform the public safety and law enforcement sectors and provide them with a wide array of critical use cases. High accuracy network location can provide a huge leap in capability, enabling these sectors to provide some life-saving services. So we'll start with a quick introduction of SS8 and kind of give you an outline of why advanced network-based location will help transform public safety and lawful intelligence. I'll take you through some of the challenges these sectors face today with generally what is available from a location standpoint. So SS8 networks, just in a nutshell, we have been around for well over 20 years. We're heavily engineering-based company. We've been deployed with 8 of the world's 14 largest communication service providers. And we are deployed in some 35 countries, covering essentially more than 1 billion subscribers. We have essentially 3 product lines, XCPO, IntelliGo, and LocationWise. These are essentially our mediation platform, our monitoring center, and then our core location platform. We have really been in location-based services for almost a full 2 decades of the 22 years that we've been around. We've been providing location solutions to emergency services, governments and law enforcement agencies worldwide. We have been an advisory board member of ENA since 2011. ENA is the European Emergency Number Association. We have provided architectural and best practice recommendations and helped audit the location accuracy and reliability of AML, Advanced Mobile Location, which is a handset-based location technology for emergency services. So getting into the heart of what we want to discuss today, really it's about public safety and the benefits of high accuracy location. As you may be well aware, much of the world's population today lives in dense urban areas, large cities. This is kind of where people have generally been moving to. And where emergency services or response numbers are provided, today more of those numbers are dialed from mobile phones than from landlines. And in places where even some type of location capability is provided, what is available is very basic. It is what we call a cell ID location level, and that is just simply identifying the cell that is serving that particular mobile device that is making the call, and that information is essentially provided to the public safety answering point or law enforcement, or the first responders. And it's not very helpful, as we'll show. Now, moving on into 5G, the location services architecture has significantly improved since the legacy networks of 2G and even 3G. And more advanced location capabilities are provided within the standards, including the ability to calculate the Z-axis, the vertical position of that device. If the device happens to be located on, say, the 30th floor of a high-rise. And also, in addition to just public safety, but even for lawful intelligence, an accurate location of a device is extremely helpful. With just simply a GMLC cell ID location, you are not given something that what we consider an actionable location intelligence. If you're in a dense urban area and your approximate location for a subscriber covers, a few hundred meters, that could be several blocks. And in a densely populated area, that's several thousand people that you are trying to sift through to find this one caller. This is the proverbial needle in a haystack. But with a more advanced network-based location, you can significantly improve that to not just to one block, but potentially even what corner of a block that this caller may be in. Now, this becomes more actionable for the first responders in case of an emergency or otherwise. So, and what else does advanced location bring us? So it will enable, actually, from our experience as well, some wide range of use cases. Obviously, the basic use case is being able to do either historical or real-time location query. Emergency services typically require real-time location query. It's, the call is made, where is this caller? And that's, you get an accurate location for that device. But in addition, there's other use cases that are enabled both for public safety and also for commercial applications, but things such as geofencing, meeting detection, and then even determining inbound roamers or outbound roamers on your network, which can be useful for border control. So these are just a sample of use cases that can be enabled with a accurate network-based location, but there are hundreds more that can be enabled with this technology. So how does it transform public safety and lawful intelligence? Well, so as mentioned, a cell ID network location, it gives you just essentially what you're doing is, this mobile device is being served by this particular cell or sector, but that sector may cover anywhere from 500 meters to a kilometer in a dense urban area. And it could cover up to 30 kilometers in a very rural area. In those environments, now your first responders or investigators have to cover a massive amount of area. And that's a lot of time wasted to search for, say, a victim or some suspect. And it becomes very cumbersome and time consuming and costly as well. So this is really a big challenge, but this is today, in most cases, this is the technology that is remotely even available for public safety. Now, where it's been deployed, or where what we want to show is with an advanced network-based location, what you've done is now in a dense urban area, for example, is you've taken potentially something that is in the a search area of several hundred meters, 500 meters, 800 meters, now down to about 50 meters, or potentially even less than that. And then in the rural areas, now you're going from something in the order of tens of kilometers to now maybe about 500 meters, maybe max 800 meters or so, and then in some cases even lower than that. And that makes a big difference. Rural areas, going from 20 kilometers to 500 meters makes a massive difference. In a dense urban area, now you can focus on a particular intersection. So the improvement and the difference is really truly transforming. And now, and I'll point out real quick too, is that we know that there are positioning methods such as AGNSS or assisted GPS, as it's more commonly known, and which are extremely accurate, and they're typically on the order of sub 5 meters when it's available. Now, that's the key question. That's the key point. There is when it's available. AGPS works great when it has good visibility of the sky. In dense urban environments, if you're inside a high-rise with lots of other building around you, or you're in a parking garage, it's not very reliable. It's also not always available when it's not an emergency call. So, or if that emergency call has been terminated, now your only method of locating that device is via the network-based technology. And that's the reason why we are focused on this particular method. So how does this really work, right? This is essentially what we call geometric multilateration. In theory, it's actually a very simple geometric algorithm. You estimate the arcs of the different signals that the mobile is able to see, to detect and measure the power, the received signal strengths, and where available the timing information. You generate those arcs, and then you calculate the intersection of those arcs. Now, in practice, it's a little bit more complex because you really have to have a good understanding of mobile networks, how they're deployed, know what data to collect in terms of your cell database, things such as the antenna beam angle, the height of the tower, even the antenna information. These are all different information data points that need to be gathered and built into the location platform, so that when the device reports these measurements, you're able to accurately calculate the arcs and the intersection and estimate a position of the device. And 5G, as we'll talk a little about in a couple of slides, is going to revolutionize how we are doing network-based location. It's going to be able to generate location accuracy that even potentially rivals AGPS accuracy. This is just kind of to give you an idea how 3GPP has evolved location services technology. This is kind of just shows you the 3, 4, and 5G networks, the core components of those network technologies. What you see in orange are the location components. The GMLC, that's the Gateway Mobile Location Center, is essentially its function has always remained the same. Its capability is the same. That's really the point of where any of a location client, such as emergency services or some law enforcement application, would connect to the network via the GMLC. And then, as you can see, from 3G to 4G and then now 5G, we have the advanced location components. These are where more precise positioning is determined. In 3G, it's the SAS, the standalone SMLC. For LTE, it's the eSMLC. And then in 5G, we have what's now called the location management function. And what 3GPP has done is, as these nodes have evolved, is baked in several more positioning methods with each subsequent generation, providing a lot more options and capabilities for different use cases. And in 5G, what is now kind of coming into the standards is the ability to calculate that Z-axis. Whereas, in previous generation networks, you needed a lot of external network capabilities to be able to do that. Now in 5G, it's kind of within the standard, it's built into the system. And because of typically the density of 5G, you're able to calculate extremely accurate positions. So, and I'll talk a little bit more about that, because 5G really provides what we believe a generational leap in the available location accuracy from using the network, right, as opposed to using AGPS or even Wi-Fi positioning. As I mentioned, you're able to match GPS level accuracy, and we now have more than 10 standard positioning methods supported with NG-RAN. And then one of the technologies available in 5G, the beamforming technology with some of these smart array antennas, which slices the base station transmissions into many spatial components, really essentially to cover, especially in dense urban areas. Its design is to cover, to give people on high floors just as good coverage as those on the ground floor. Well, what this allows you to do is to use those beam formations to essentially calculate where that device, on what floor that device is located. And because of the density really required in 5G, the intersite distance typically is expected to be under 500 meters in between sites, which is designed so that 5G delivers what it promises in terms of latency, data throughput, and capacity. But then that also translates into extremely accurate positioning capabilities. So just as a snapshot, this is really, if you look at how the positioning technology has evolved from 2G, 3G, 4G, and 5G, you can see the difference. Whereas in 2G and 3G, that even what was typically available somewhere in the order of a couple hundred meters, in 4G that significantly improved, and then now in 5G you're looking at almost GPS level accuracy. So and that's really what we see can be truly transforming for public safety and for lawful intelligence. Okay, and that's really kind of the presentation I wanted to make to you today, and this is really what SS8 is about. Our mission is really to provide the most advanced lawful and location intelligence solutions available. We are constantly working on our solutions and evolving with the standards, building we have a lot of talented people who are extremely involved in location technology, and this is we really, our goal has always been to be able to provide the tools to public safety, law enforcement, to be able to save lives. That is really the core of our mission. So, and if you have any questions, please feel free to shoot me an email. My email address is michaelg@ss8.com. You may also contact SS8 directly for any information that you would like, sales@ss8.com, or +1 408 944 0250. We can be reached at any time for additional information. And I want to thank again Ariana and the Fast Mode for this opportunity to talk a little bit about SS8 and what we can do.
Okay, so that wraps up today's webinar. Thank you, Michael, for the brilliant presentation, and thank you to everyone tuning in. Hope you found this session insightful. To learn more, download the white paper Impact of 5G on Location Accuracy and Lawful Interception at bit.ly/5G Location Accuracy. Or check out the 3 other resources listed on this slide. The links to the white paper and these 3 resources can be found in the chat column on your right. If you have any questions, please email ariana.lin@thefastmode.com and we will get back to you as soon as possible. Have a good day and see you again.